about distance and midpoint. The learning objectives for today are: you are going to define distance between 2 points and midpoint of a segment. Derive the distance formula and the midpoint formula. And determine the distance and midpoint between 2 points. Let us have first the distance formula. The distance between any 2 points on a number line, horizontal or vertical, can be found by simply finding the length of the segment determined by these points. Look at this number line. The distance between A and B, which is denoted by segment AB, is segment AB is equal to the absolute value 5 minus 1, wherein it is equivalent to the absolute value of 4. And the absolute value of 4 is equivalent to 4 units. So the distance from A to B is equal to 4 units. Using this number line in vertical form, the distance between C and D is denoted by segment CD, which is equivalent to the absolute value of 3 minus negative 3. And simplify this, we will have 3 plus 3 is equal to the absolute value of 6. And the absolute value of 6 is positive 6. So the distance from C to D is equivalent to 6 units. You may interchange the number. If you wish to start with D, then followed by C, you can do it. And the answer is still the same because you are taking the absolute value of the number. Next, the formula for finding the distance between 2 points on a number line. If x sub 1 and x sub 2 are the coordinates of A and B, respectively, on the horizontal number line given in the previous slide, then the distance between A and B is denoted by segment AB, or the distance from A to B, which is equivalent to the absolute value of x sub 2 minus x sub 1. This can be represented by x sub 1 and this one x sub 2. If y sub 1 and y sub 2 are the coordinates of C and D, respectively, on a vertical number line, then the distance between C and D is denoted by segment CD, or the distance from C to D, equivalent to the absolute value of y sub 2 minus y sub 1. So, in this illustration, the value of C is y sub 1 and the value of D is the y sub 2. Let us have an example. Find the following distance from R to P and next from U to S. Let us start first in this segment. The coordinates of R, we have negative 6 and 1. The coordinates of P, we have 2 and 1. And for U, we have 8 and 7. For S, 8 and negative 5. So for the solutions, point R and P have the same ordinate, that is equivalent to 1. So it's here, 1 and 1, because the segment passes through 1. The distance from R to P is equivalent to the absolute value of 2 minus negative 6. because you will take this as your x sub 1 and this is your value for x sub 2. And this is equivalent to the absolute value of 8, and the distance from R to P is equivalent to 8 units. Next, points U and S have the same abscissa, which is 8, because the segment passes through x equals 8. So, segment US is equal to the absolute value of 7, which is the value of y sub 2, minus negative 5, the value of y sub 1. And simplify, the result is the absolute value of 12. Because negative times negative 5 is positive 5. So, the distance from U to S is equal to 12 units. Take note, these concepts on the distance between 2 points on a number line will be applied in deriving a formula for the distance between any 2 points on a Cartesian coordinate plane in terms of their coordinates. So, let us have the distance formula now. The distance between 2 points represented by P sub 1 with coordinates x sub 1 and y sub 1, and P sub 2 for the second point with coordinates x sub 2 and y sub 2 is equal to the square root of the square of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. For the derivation of the distance formula, if we are going to let P sub 1 with coordinates x sub 1 and y sub 1 and P sub 2 with coordinates x sub 2 and y sub 2 be points on a Cartesian coordinate plane, and let Q be a point where an imaginary horizontal segment through P sub 1 intersects an imaginary vertical segment through P sub 2. So in this illustration, so this point is P sub 1. This point is represented by P sub 2. And you have point Q as the intersection when you draw a horizontal line from P sub 1 to Q and drawing imaginary vertical line from P sub 2 to Q. Note the information of the right triangle P sub 1, Q, P sub 2. The distance between P sub 1 and P sub 2 is the same as the length of the distance from P sub 1 to P sub 2. By Pythagorean theorem, then we have the square of the hypotenuse P sub 1, P sub 2 is equal to the square of the base, which is P sub 1Q, plus the square of the altitude P sub 2Q. But P sub 1Q is equal to the absolute value of x sub 2 minus x sub 1. And P sub 2Q is equal to y sub 2 minus y sub 1. Therefore, the square of P sub 1, P sub 2 is equal to the absolute value of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. Since P sub 1, P sub 2 is non-negative, then P sub 1, P sub 2, or the distance from P sub 1 to P sub 2 is equal to the square root of the square of the difference of x sub 2 and x sub 1 plus the square of the difference of y sub 2 and y sub 1. Take note that the square of the absolute value of a number is the same as the square of the number. So that is why the distance formula is in this form. Let us have an example. Use the distance formula to find the distance between the given pair of points A and B, where A with coordinates -3 and 1 and B with coordinates 0 and 5. For the solutions, point A with coordinates -3 and 1, so x sub 1 is -3 and y sub 1 is +1. Point B with coordinates 0, 5 is x sub 2 equivalent to 0, and the second y coordinate as y sub 2 is equal to 5. So using the distance formula, all we have to do is to substitute. Since the first point is A and the second point is B, so let us use segment AB, or the distance from A to B is equal to the value of x sub 2 is 0 minus x sub 1 is -3. Then you take the square plus the value of y sub 2 is 5 minus the value of y sub 1 is 1. Then you take the square. Then simplify. We have negative times -3 is +3. Then you square. 5 minus 1 is 4. Then you take the square. And the square of 3 is 9. The square of 4 is 16. Add 9 and 16, it is 25. So the square root of 25 is 5. So the distance from A to B is equivalent to 5 units. Next. Example number 2. Use the distance formula to find the distance between the given pairs of points C and D, where C with coordinates -2 and 5 and D with coordinates 6 and 1. For the solutions, we have, for the first point, we consider this -2 as x sub 1 and 5 as y sub 1. For the second point, 6 is the value of x sub 2 and 1 is the value of y sub 2. Using the distance formula, we have to substitute all the values and then we have to simplify. 6 minus -2, that is equivalent to 8, then we are going to take the square later. Then 1 minus 5 is -4, then you take the square. So the square of 8 is 64, the square of -4 is 16. 64 plus 16 is square root of 80. And then we have to simplify 80 by taking the factors. One of the factors is a perfect square. So that is 16 and 5. The square root of 16 is 4. Then copy square root of 5. So the distance from C to D is equivalent to 4 times the square root of 5 units. Next, let us have the midpoint formula. If P sub 1 with coordinates x sub 1 and y sub 1 and P sub 2 with coordinates x sub 2 and y sub 2 are any two points in a coordinate plane, then the midpoint M of the distance from P sub 1 to P sub 2 has coordinates. For x, we have x sub 1 plus x sub 2 over 2. And for y coordinate, we have y sub 1 plus y sub 2 over 2. And this is the midpoint formula. The midpoint of a segment is the point on the segment that determines two congruent segments. So in this illustration, the points on the horizontal segment drawn on a Cartesian coordinate plane have the same coordinates. Thus, all the points on the segment whose endpoints negative 2 and 5, and 3 and 5, including its midpoint, must also have 5 as its ordinate. So, the ordinate of this midpoint is also 5 because the segment passes through y is equal to 5. The midpoint M, according to the definition, lies between the endpoints. Its ordinate is 5, and its abscissa is the average of the abscissa of the endpoints. That is, M with coordinates represented by x sub m and y sub m is equal to negative 2 plus 3. This is x sub 1 plus x sub 2 over 2. Then the y coordinate or the ordinate is 5. Then simplify, what we have is 1/2 for the value of the x coordinate or the abscissa, and the ordinate is 5. So the coordinates of M, we have 1/2 and 5. Next, consider a segment with endpoints A and B, where A with coordinates 3 and 1, B with coordinates 5 and 9. To determine the coordinates of the midpoint, represented by M, draw the horizontal and vertical segments as shown in the figure. The intersection of these segments is H with coordinates 5 and 1. The midpoint N of the horizontal segment is N with coordinates x sub m and y sub m, which is equivalent to 3 plus 5 over 2, and the ordinate is 1. Then simplify this part, then we have 8 over 2, which is equivalent to 4 and 1. So the coordinates of N, we have 4 and 1. The midpoint of V of the vertical segment is 5 as the value of the x coordinate, and for y sub 1, we have 9 plus y sub 2, which is 1 over 2. The 9 plus 1 is 10 over 2, which is 5. So the coordinates of V are 5 and 5. Take note, x sub m and y sub m, this one refers to the x and y coordinates of the midpoint. The points on a vertical segment have the same abscissa. These points, N with coordinates 4 and 1, V with coordinates 5, 5, suggest that the coordinates of M are 4 and 5. To check if M with coordinates 4 and 5 is the midpoint of the segment whose endpoints are A with coordinates 3 and 1 and B with coordinates 5 and 9, the equation segment AM is equal to segment BM must be true. So for the solutions, we have to use the distance formula. Let us have first segment AM, this part. Substitute the values. We have 3 minus 4, then take the square, plus 1 minus 5, then take the square. Then simplify. Square of 1 is 1, the square of negative 4 is 16. So we have square root of 17. So the distance from A to M is square root of 17. Next, from B to M, we have 4 minus 5 plus 5 minus 9, then you square. Simplify, we have negative 1, and here we have negative 4. The square of negative 1 is 1. The square of negative 4 is 16. So the answer of BM is square root of 17. Since AM is equal to BM, Then M is the midpoint of segment AB. Let us have an example. Find the coordinates of the midpoint M of the segments whose endpoints are with coordinates -7 and 6 and -5, -1. For the solutions, we have, using the midpoint formula, in this point, -7 is the value of x sub 1 and 6 is the value of y sub 1. And for the second point, -5 is the value of x sub 2 and -1 is the value of y sub 2. So substitute to the midpoint formula, we have -7 plus -5 over 2 and 6 plus -1 over 2. When simplify, we have -7 plus -5 is -12 over 2. 6 plus -1 is 5 over 2. And you can simplify -12 over 2, which is -6. And you can copy 5 over 2. So the coordinates of the midpoint, we have -6 and 5 halves. Example number 2. Find the coordinates of the midpoint M of the segments whose endpoints are with coordinates 1, 0, and the second with coordinates 5 and 2. So for the solutions, x sub 1 here is equivalent to 1, y sub 1 is 0. For the second point, x sub 2, we have 5, and y sub 2 is 2. Using the formula for the midpoint, all you have to do is to substitute the values. For x sub 1 is 1, x sub 2 is 2, y sub 1 is 0, y sub 2 is 2. And then simplify, we have 6 over 2, 0 plus 2 is 2 over 2. Simplify further, 6 over 2 is 3, 2 over 2 is 1. So the coordinates of the midpoint, we have 3 and 1. Next example. Find the coordinates of the midpoint M of the segments whose endpoints are with coordinates -5 and -4, and 1 and -1. For the solutions, x sub 1 here is -5, y sub 1 is -4. On the second point, we have x sub 2 as 1, y sub 2 is equal to -1. Using the formula, substitute the values. So we have -5 plus 1 over 2 and -4 plus -1 over 2. Then -5 plus 1 is -4 over 2. -4 plus -1 over 2 is -5 over 2. And what we have is -2 and -5 over 2. So the coordinates of the midpoint, we have -2 and -5 halves. Do you have questions? If there is none, see you next time. Bye!